Hey y'all, welcome to Miss Clark's chemistry class. In this lesson, I'm going to teach you how to draw electron dot structures for covalent molecules. Now, electron dot structures, Lewis dot structures, it's the same thing. Those two phrases can be interchanged. Sometimes I interchange them. So please do not get confused if I say Lewis dot structure or electron dot structure, same thing. I do have another video on this exact same topic, but I am going to draw the structures in this video in a different way. I believe the way I'm about to teach you is the most simplified way to learn. So go get your notes, make sure you have a periodic table, and let's get started. Okay, so before we start actually drawing these compounds out, these molecules, let's remember some things about covalent bonds. Covalent bonds are going to be between nonmetals and nonmetals. Nonmetals are very electronegative, so they are good at attracting electrons towards themselves. But if they're attracting electrons to themselves and the other nonmetal is attracting electrons to themselves, they're going to end up sharing these electrons. So let's remember that this bond forms when the valence electrons are shared. Now, we did talk about there being two different types of covalent bonds, polar and nonpolar. That is not going to come up in this lesson. Okay, let's look at our periodic table and remember a couple of things before we go any farther. So remember how you can look at your periodic table to tell how many valence electrons are in the representative groups. Remember, that's the tall groups. In group 1, there's 1 valence electron. In group 2, they all have 2 valence electrons. And then we're going to skip over because we're just talking about the tall groups. Group 13 has 3 valence electrons. Everything in group 14 has 4 valence electrons. Everything in group 15, 5, 16, 6, 17, 7, 18, 8. Some people always just remember it because you count 1 through 8 just across the top. Some other people like to think about how it correlates with the group number. Group 1, 1 valence electron. Group 2, 2. Now, I realize over here, but this is group 13. There is that 3. Group 14, there is that 4. Whichever way you like, but make sure that you always remember that. Okay, so let's move on to the rules because there's actually a couple of rules to this. Okay, so rule number 1. Single dots are for bonding. Double dots are not. For example, you know what? Rule number 2 is going to take care of that example. So let's keep rule number 1 in mind, and let's go ahead and go to rule number 2. Halogens and hydrogen always are on the outside. Now, these might not all be in a line. Outside, I'll explain that once we get going. But halogens and hydrogens have to be on the outside. Let me explain that because it's going to show you rule number 1 and rule number 2. First, we need to remember that halogens, this is group 17. So an element from group 17 might be chlorine. Group 17, that's 7 valence electrons. So 1, 2, 3, 4. You see how I'm using the element almost like it's in a box, and I'm going around the 4 sides until each side has 1 dot, then I'm doubling up. So I have 4, 5, 6, 7. Double dots. This is called a lone pair. No bonding happens here. It's almost like a parking spot, but it's got a car in it. You can't park there. Here is a single dot. This is a bonding electron. This is where a bond can happen. If we notice, chlorine only has 1 bonding electron. The rest of its electrons are paired up. Lone pair, not good for bonding. Lone pair, not good for bonding. Lone pair, not good for bonding. Chlorine, all halogens, can only make 1 bond. So they always need to be on the outside. Let's look at hydrogen. Hydrogen is in group 1. It only has 1 dot. Hydrogen's electron configuration is 1s1. Hydrogen only has an S, not a P, just an S. And a full valence means a full energy level. Hydrogen only uses that first energy level, and it only has one electron in that first energy level. That first energy level can hold 2 electrons. So hydrogen will have a full valence with 2 electrons, not 8. I know, it's a little bit different. But see, we just kind of looked at why. It only has the first energy level. It only has an S, and S can only hold 2. So hydrogen's happy with 2. Everything else just about is happy with 8. Hydrogen, happy with 2. Hydrogen has only one single electron, and that single electron is a bonding electron. Hydrogen will only make one bond. Again, one bond. It's got to be on the outside. I promise, I'll get to what being on the outside means in just a second. Let's look at rule 3. If carbon is available, so the compound that you're drawing the electron dot structure for, if carbon is there, carbon has to be in the center. Let's look at rule 2 and 3 together real quick. If we were going to draw the structure for CH4, all nonmetals, carbon is there. Carbon has to be in the center. Hydrogen is also there. Hydrogen always has to be on the outside. There's 4 hydrogens. I'm going to put them all on the outside with carbon staying in the center. So we would place hydrogens on all 4 sides, just like we were going to do dots. This is what we're going to be doing, arranging these atoms and drawing their bonds. Carbon always has to be in the center if you have it. Hydrogens and halogens always have to be on the outside. And here's a good example of what that looks like. Okay, rule number 4. Okay, last rule. Not really a rule, but just a little guideline to kind of help you out. Sometimes you'll have multiple elements and you'll try to figure out how to place them. Try and make your structure as symmetrical as you can. That will always help you line everything up. The very last example that I'm going to do is going to use that, and so make sure and stay till the very end so you can see that rule in action. Let's practice. Y'all, make sure you are copying these down in your notes. Don't just watch me do it. Oops, I completely forgot. We still need to talk about single bond, double bond, and triple bonds. A single bond is worth 2 electrons. 2 dots is going to make 1 bond, and we call 1 bond a single bond. A double bond is going to be 4 electrons. You'll have 1 bond, 2 bonds. They'll actually look like this, like an equal sign. 2 bonds, and so it's worth 4 electrons. This single bond, you would look like this. You could either draw it with 2 dots or a line. Each line represents 2 dots. This bond is made out of these 2 dots. You can represent that bond either way. This double bond is represented with 4 dots. 2 dots to make 1 bond, 2 dots to make the other bond. A double bond is worth 4 electrons. And so a triple bond, you probably already see the pattern, don't you? It's going to be 6 electrons because you're going to have 3 bonds. 3 bonds. Each bond is worth a pair of electrons. So our 3 bonds is worth 6 electrons. All right, now let's do some examples. I wanted to start with the compound I thought was the easiest, H2, hydrogen gas. Now to start, we need to write the 2 symbols and we need to organize them using those rules that we talked about. But if you only have 2 elements, you're just going to put them side by side. Next, we need to draw each element's electron dot structure. Hydrogen, group 1, 1 dot. So I'm going to put hydrogen's 1 dot here. Now I'm always going to try to put the single dots between the elements that I'm trying to bond together, because the single dots are where the bonds are happening. The double dots, no bonds are happening. So I want those to be arranged on the outside. But for hydrogen, there's only 1 dot. Each hydrogen gets its 1 dot. Covalent bonds share electrons. Hydrogen, remember that weird hydrogen, only wants 2 electrons to have a full valence. And so this hydrogen here, when it gets close to this other hydrogen, they're going to share these electrons and they're going to make a bond. We're sharing them. When they're being shared, this hydrogen here feels like, because it's sharing, it has these 2 electrons, hydrogen, happy. This hydrogen also has its own valence electron, and then it's counting this electron as its own as well because they're sharing it. So both hydrogens feel like they have 2 electrons. Hydrogen can only make 1 bond. This hydrogen has 1 bond. This hydrogen has 1 bond. Okay, so that's hydrogen gas. Let's look at another example. NH3. Y'all, NH3 is actually a super common compound. It is ammonia. Ammonia is a cleaning solution, not vinegar, but ammonia. It stinks real bad. Anyway, ammonia is NH3. Now, we don't have any rules about nitrogens. We only have a rule about carbons being in the center. Not there, so we can't really think about that rule. And we do also have a rule about hydrogen. We know that hydrogen has to be on the outside. So as I start to draw this, I'm going to put nitrogen on the inside since hydrogen has to go on the outside. So I'm going to do nitrogen, and I'm going to have hydrogen, hydrogen, and you can either put one on top or bottom. It really doesn't matter. I'm going to put it on bottom. Okay, so we've got our elements arranged. Now we need to put our dots on our elements. Well, we just talked about hydrogen. Hydrogen's in group 1. It has 1 dot. So I'm going to put 1 dot on all of my hydrogens. Nitrogen is in group 15. Guys, if you don't have your periodic table, pause and go get it. Do not let me sit here and tell you how many dots. You really need to see it on the periodic table, so when you don't have me in your ear, you will know what to do. Nitrogen, group 15. Do you see that? 5 dots. 1, 2, 3, 4, 5. And y'all, I purposefully put these 3 single dots here because there's hydrogens here. And I purposefully put these double dots away from the hydrogens. So let's look at the sharing that is going to happen. It fits together like a puzzle piece. That's why I like this version. These are going to share and make a bond. These are going to share and make a bond. And these are going to share and make a bond. The single dots are going to connect like a puzzle piece. Now, if we redraw this, we've got nitrogen bonding to 3 hydrogens. And I'm going to draw the bond with a line instead of the dots. But we can't forget to include this lone pair. Remember the lone pair? That's the double dots that you can't put a bond on. NH3. That kind of came together pretty easy. I hope you agree. Let's look at another example. CO2. This is carbon dioxide. You know the stuff we breathe out and the stuff plants breathe in? Carbon dioxide. We need to place our elements first. Place our elements. Carbon is available. Carbon must go in the center. And we've got 2 oxygens. So I'm going to put those on either side. Now we need to put our dots. I'm going to start with oxygen. Oxygen, find it on the periodic table. What group number is it in? How many valence electrons? Group 16, 6 valence electrons. 1, 2, 3, 4, 5, 6. Again, I put my double dots away from the center on purpose. This oxygen will also have 6. 1, 2, 3, 4, 5, 6. See how I modeled that behavior? Carbon. Find carbon on the periodic table. Carbon, group 14, 4 valence electrons. 1, 2, 3, 4. When you draw these really close together, I'm hoping that the puzzle kind of puts itself together. Now this one is a little bit different. Let's look at this. These 2 dots are right beside each other. 1 dot from oxygen, 1 dot from carbon. These are going to share. This is kind of symmetrical. So the exact same situation is happening over on the other side. These are also going to share. But are we noticing that carbon still has single dot, single dot? And are we noticing that oxygen still has single dot, single dot? You are not done until all of your dots are paired up. Now this is going to get a little bit messy, but let me show you what happens. This dot and this dot are going to reorient themselves. I'm not going to redraw it with them reoriented, but they're going to reorient themselves and they're going to share. And then the same thing is going to happen with these single dots. Now let's clean that up a little bit. Carbon was in the center and it has 2 bonds bonding to the oxygen. 2 bonds bonding to the oxygen. Do not forget, we do want these extra lone pairs. They're a part of the situation. Don't leave them out. And then we're going to do the exact same thing on the other side because we want symmetry. Carbon dioxide. Carbon dioxide, double bond. But you see how that double bond kind of put itself together? You just got to pay attention to where the single dots are. Let's do another example. N2, nitrogen gas. I'm going to put my N's beside each other. They're the same letter, so there's really nothing to think about. Nitrogen is in group 15. We just said that a second ago. So 5 dots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Did you notice how I put those double dots on the outside here? And if you don't, it's okay. It just gets a little bit more messy, and that is okay. Okay, so let's start looking where the sharing is happening. Okay, so this is easy to see that this sharing is going to happen here. Y'all, are you noticing this? Single dot, share. Single dot, share. Nitrogens are held together with a triple bond. Nitrogen, triple bond, nitrogen. Let's not forget this lone pair. Puzzle pieces, y'all, puzzle pieces. But you got to be drawing your electron dots. If we would have drawn nitrogen with 5 random dots, no puzzle that would make. I know I have at least one more example, maybe 2. Y'all, I looked ahead. This is the last one. Now, this one looks kind of big. Don't let that be scary. Lots of elements, that's okay. Most of the time when you have multiple elements, it lines itself up pretty easily. Now, we have carbon and hydrogen, and we have rules for both of those. Carbons have to be in the center, hydrogens have to be on the outside. Let me show you what that looks like. We're going to put carbon in the center, and we're going to put hydrogen on the outside. We got 6 of them. See how we just wrapped them all the way around the carbons? Let's put dots. Hydrogen, 1 dot. We've said that several times. You'll start to memorize a few of these on accident without trying, just from using them a whole lot. Carbon, find carbon again. Group 14, 4 dots. Okay, that carbon has 4 dots. This carbon has 4 dots. Let's start linking them together and showing where the sharing happens. You see how easy this one came together? And y'all thought this one was going to be hard. Share, 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 share. When we clean that up, we're going to have a carbon bonded to a carbon, bonded to 3 hydrogens, bonded to 3 hydrogens. Symmetry. Symmetry helps line everything out. That really wasn't very hard, was it? It all fits together just like a puzzle piece as long as you're drawing your Lewis dot structures the way I taught you. I sure hope you wrote all of these examples down in your notes. Until next time, bye y'all!